It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about t distribution. What is really t distribution? Now, this is another distribution aside from your z distribution that we've learned so far. We've got another t distribution in which they are more likely the same, but only that t-distribution is more likely used for a smaller sample size. So let's try to get to know what is really a t-distribution. Okay, t-distribution is also known as student's t-distribution. You have to know that one, otherwise some of the teachers might be using student's t-distribution instead of only using the t-distribution as the name of the distribution. And then please know that when you say t-distribution, this is coming from normally the mean, or the given here is the mean of a sample which is less than or equal to 30. So again, t-distribution is for a smaller sample size. And then, of course, the standard deviation also of the population is unknown. So when the two are given, then more likely you are going to make use of the t-distribution to analyze or to solve a certain problem. So again, mean is given, which is coming from a sample which is less than or equal to 30, and the standard deviation is unknown, then you have a great opportunity of using the t-distribution. And then it is also known that when you say t-distribution, this is coming from the family of bell-shaped curve. Why is it a family of bell-shaped curve? Because your distribution would look like a bell-shaped curve. So again, this is somewhat related, or they are more likely the same with your z distribution. Only that your sample here are less than 30. Another one, when we talk about t-distribution, we are more likely considering the degrees of freedom, which specifies a particular curve. When you say degrees of freedom, this refers to the number of independent observations in the set of data, or the number of variables that are free to vary. Now, more likely, this is just simply n minus 1. So from the sample size, we subtract it by 1, and that's our degrees of freedom. So what does it mean? This would simply mean that the n minus 1 there is the number of variables that are free to vary. So here is now the comparison, or more likely how you compare your t-distribution with your z-distribution. The green there is your standard normal distribution, which is of the bell-shaped curve. And of course, when you say t-distribution as well, this is a family of the bell-shaped curve, so we are expecting that the t-distribution would also look like a bell-shaped curve. Only that your curve there is distinguished by the different degrees of freedom. If you try to look at the different colors, you've got there, the first one is with your 1 degree of freedom. So this is now your df, which is equal to 1. That is now how your t distribution would look like. And your blue there is the t with 2 degrees of freedom. So if you try to look at that one, you've got there your t distribution is approaching towards your standard normal distribution as your degrees of freedom becomes bigger. I hope that's clear. Or if you try to look at that one, degrees of freedom is coming from n minus 1. So as you try to increase your sample size, of course, it will be approaching towards a normal distribution. So I hope that's clear. Next one is, here are the different properties of a t distribution. So more likely they are similar with our z distribution. So first one is, the distribution has mean which is equal to 0. So as you can see there on the graph, on the illustration, your mean there is equal to 0. So it has the same property with your z distribution, that the center or the median of your data is 0. And of course, your mean, your mode, and your median are also the same. Next, we have the distribution is symmetric about the mean. So meaning to say that your curve there is divided into two equal parts based on the mean, or as your line of symmetry, which is your mean in there. And then the variance is equal to df over df minus 2. So if we are to calculate later on the variance of the t-distribution, we have now the formula, which is df over df minus 2. So that's a lot easier. And then we have the variance is always greater than 1, but approaches 1 when df gets bigger. So I hope it's clear. So the last two properties there are the only different on the properties of your z distribution and the t distribution. But most likely they are the same. Your curve there is infinite, meaning to say it goes on forever. It's not infinite, sorry for the word. It's continuous. That means to say it does not end. It goes on forever towards your right side and left side. And then, of course, your curve there is asymptotic to with respect to your horizontal axis, meaning to say it approaches towards your horizontal axis but never touching it. So that's asymptotic. So I hope it's clear. Now let's move on to how do we read our t-table. Because before we apply this one, or before we use t-distribution in our computation later on, we need to know how to read our t-table. So this is now the t-table, in which you might have different t-table there, but let's try to know what are those things that we need to know when we are using our t-table. So first off, we must know our df. Our df is located on this column here. So if you can see there on your table, there's the df, and everything here is your df. df, remember, that is n minus 1. Now next is at the top, or at the header, you have here one tail and you've got there two tails. So if later on, if your problem is talking about one tail, then you are going to refer to that header and look for the df with respect to that header. And under one tail, you've got there the values 0.5, 0.25, 0.20, and so on. Those are actually what we call as the alpha. The alpha here, this is also what we call as the level of significance. So what do we mean by level of significance? Now, level of significance, this is now our value in which a researcher would like to set, in which this is the highest value of p that we are willing to tolerate and still say that a difference or change or effect observed in the sample is statistically significant. So to say it, this is now the allowable value that we need to consider when we wanted to reject our null hypothesis. Later on, you would know that one under hypothesis testing, all those things I've mentioned, but right now we are not more concerned of that one. Later on, I'll be discussing thoroughly what is level of significance and how is it really important on your studies later on. Now, let's focus on this one. Alpha is the level of significance in which that is very much important when we wanted to solve for our t-values later. So, based on the problem, you will be given, of course, the level of significance as what the researcher have set as allowable value for your study. Now, sometimes it's not given. I mean, the level of significance or the alpha there is not given. So sometimes the one that is given is the level of confidence. So please know this one, because your teachers might not be discussing about level of confidence, but you will be encountering later on problem with regards to the level of confidence. Now, when you say level of confidence, this is now the opposite of the level of significance. When you say level of significance, this is now the allowable value that we are considering for the rejection region. Level of level of confidence here is the opposite. So this is now our acceptance value. So let's say, for example, if I wanted to say my level of confidence is 95%. What does it mean? This would simply mean that 95% is my assurance that I will be accepting my hypothesis, or I would agree to what is being stated, or what is being declared on as a value. So that is how you consider the level of confidence. But anyways, you will be understanding everything that I'm talking about later on during the hypothesis testing. But there is a relationship between the level of confidence and the level of significance here. When you say level of confidence, this is equal to 1 minus the alpha. So that's your level of confidence. So please know that one. If you are looking for the level of significance, if you're given the level of confidence, then you would have it as 1 minus the level of confidence. So please take note of that. So I hope that's clear. Now, most likely the level of confidence are bigger in value. Let's say if I'm going to have this example here, find the two t-values that give the middle 90% of the distribution when the sample size is 18. This 90% is much bigger. This is not our level of significance. This is not the alpha there, but this is the confidence level or the level of confidence. Because it says there, find the two t-values that give the middle 90% of the distribution. So middle 90% of the distribution. Since it says there, middle 90%, so that would simply mean that we are expecting that 90% is more likely found here in the middle. So that means to say it's between this value. So this might be our 90%. And of course, this one is, since it should be divided into 2, they are both equal. So our level of significance here will be, again, as I mentioned, this is the level of confidence because it's way too big. So our level of significance, the alpha there, is simply equal to 100% minus 90%. So that is equal to 10%. So that's your alpha with respect to the level of confidence there. So again, when you say level of confidence, it's 1 minus the alpha, or you can have it as 100 minus the level of significance. Now, when you're looking for the level of significance, that will be 1 minus your level of confidence. So I hope that's clear, everyone. And going through, we know that alpha is equal to 10. So how do we get the t-value there? Since this is more likely two-tailed, how would we know if that is two-tailed? That will be dependent on this one. It says there middle 90%. So since that is in the middle, of course, you are expecting that you've got there the side values. So that will be two-tailed. And of course, since that is two-tailed, we are going to divide our alpha into 2. So this will be 0.05. Or this is 5%, sorry. Or that is 0.05. And of course, this one also is 5%, or this is simply equal to 0.05. Now, this is now our level of significance for the other tail and the level of significance for the other tail. Now, how would we look for these values? So this is now what we are after, finding the t-values that give the middle 90% of the distribution when the sample size is 18. So we are given now the sample size, which is 18. So how would we use our t table there. Sorry, I'm so used to z table. Now, how do we look for the t values in there? Why t values? Because we got there two-tailed. We are expecting that we will have two t values as well. So how do we find it? We need the information on the level of significance. We have that there, 10%. And then we need the information for our DF. And we know that it's two-tailed. So two-tailed, we are going to look for that alpha here under the two-tail. So since that alpha is 10%, or more likely converted to decimal as 0.1 or 0.10, so that means to say that this is the value that we are looking for on the t table, the value for your alpha, of course. Next is we are going to look at the DF. DF here, as we all know, DF is equal to n minus 1. So we've got n there, which is 18 minus 1. Our DF there is equal to 17. So we need to look for this one also on the table. So looking, we have there DF is 17. 17 is here on the column under DF. So we will be doing the same thing as what we did on the Z table. We move across, and on the header, the point 10 there under two-tail, we are going to move down. And the intersection, that is our t value. So our t value here is equal to, that's 1.740. But since this is two-tailed, we have this value here and this value. So we are having a positive and a negative t value. So we have t, which is equal to positive 1.740. That is somewhere here. So we have 1.740. That's positive. And we have also negative 1.740. So I hope that's clear. That is how we are going to look for the t values using the t distribution table. So first, we need to know our level of significance. If the level of confidence is given, then you can make use of your this relationship in which your level of significance will just be equal to 1 minus the level of confidence. Or if you wanted to look for the level of confidence, then you have 1 minus the level of significance. Now, one thing also to read that one, if you've got there a two-tailed or one-tailed, and you are going to look for the level of confidence there, you've got 90%. You've got here under the table or at the bottom part of the table, the level of confidence. You can refer to that one. We've got 90% for that one. And then if we have a two-tail, then we have to move. This is under that one, by the way. So we just have to move up, and you are to consider the DF, which is 17. Moving across, you still have the same value. So I hope it's clear. You can actually make use of the level of confidence in there to find right away your t value for that given problem. Now, why am I going through with the level of significance here? Because most of the problem are in terms of level of significance. So might as well discuss that one to you. So I hope it's clear. Okay, let's now move on to the next problem. So next problem is find the t-value that gives the lower tail area of 0.05 when the degrees of freedom are 6. So again, when we are going to solve for our t-value, we need to know the information. First off, we need to know the alpha or the level of significance. The level of significance there is 0.05. 0.05. So sometimes your level of significance is not given, so you have to really understand your problem in there. So some of the problems are giving you that this value is the alpha or the level of significance, so you have to be familiar of those things. But this time, you were not given that this one is the level of significance. But if you wanted to really analyze that one, find the t-value that gives the lower tail area of 0.05. So again, when you say alpha, this is just the rejection region, or that's the tail part area of your distribution. So it's 0.05, so that becomes our alpha. So we have there 0.05. And of course, we need to know our degrees of freedom. So since on the problem there, the degrees of freedom is given already, we have their degrees of freedom are 6. So we have that one as 6. So if I'm going to plot this one on our distribution there, when we say 0.05, more likely this is somewhere here. But we're not so sure on that one, if that is really in between -2 and -1. But let's try to find that out. Might be I'm mistaken in there, but more likely the area here is this one, which is your alpha there, or the level of significance. So it's 0.05. So how to locate the value there, or how to find the t-value? You just have to look for the alpha, which is 0.05, under one tail. This is one tail only. Lower tail, if it's lower tail, it's found on the left side. So take note of those words. Now, because when you say one tail, you will have there a lower tail, upper tail, or left tail and right tail. So please take note of that one. But without those things, that means to say you've got there two-tailed problem. Okay, or two-tailed distribution. So anyways, let's move on to finding the t-value. We've got there the alpha, which is 0.05, and that's one tail. So we have that value here. And then we have the df, which is 6. So we have this one. We move across, and then we go down based on our alpha there for the one tail. And this is our value, which is 1.943. So t is 1.943 based on the table. But since this is lower tail, everybody, please take note of that one. Lower tail, left tail, that is with the negative sign. So without the negativity in there, that's automatically wrong. So please take note of that one. So that means to say this is negative 1.943. I hope that's clear. Now next, let's go to the next problem. Find the t-value that gives the upper tail area of 0.10 when the sample size is 15. So what does it mean? We are looking for the t-value that gives the upper tail area, which is 0.10. So upper tail, that means somewhere here on the right tail, and it's 0.10 as an area. So more likely this one, but I'm not saying if this is really the correct position of my t there. But anyways, we'll know that one when we look for the t-value. So we have the given information. This is your alpha, by the way, the level of significance, which is equal to 0.10 or 10%. So we have alpha is 0.10. And then we have our sample size. This time we are given with a sample size, which is 15. So we are now going to look for our df. Again, df, the degrees of freedom there, that's n minus 1. N is 15 minus 1, that's 14. So we have those information already. We're now ready to look for the value on the t distribution. So important things, alpha is 0.10 and df is 14. So locating your alpha, 0.10, that's one tail, because that's only upper tail. So 0.10 on one tail is this one. And then we've got 14 as your df, which is this one. So you move across and then you go down. This is now your value, which is 1.345. So our t value is 1.345, and it's positive because we've got the upper tail that's positive with a positive t-value. So I hope that's clear, everyone. So this is 1.345. Sorry for the drawing. It's not accurate. It's more closer to 1. Anyways, so we're just assuming there because we don't know the t-value in there. So that's it. Now, that is it. That's the end of the video. So I hope you were able to learn something. So if you are confused, you kindly comment down below because I'm ready to make another video if you wanted to do a clarification with on something. So I'll be making another video for you just to let you understand everything. So again, this is your teacher Jenny, and I'm hoping that you are well and fine at home during this pandemic time. So again, please don't forget to like, share, and subscribe, and kindly hit the notification bell so that you will be updated on my latest video. Once again, thank you and goodbye.